One of the defining features of the Arctic and Antarctic regions are their polar ice caps, endless sheets of ice miles thick in some places that play a key role in their reputation as freezing cold and barren regions that are largely inhospitable to human life. However, in order to reach the ice caps today, one needs to travel thousands of miles north or south, far from any human civilization. But what if I told you that thousands of years ago, there was a time when these ice sheets extended as far south as present-day Chicago and Paris? This is what we call an ice age. Now, before we get into the frozen past, I'd appreciate if you would like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so what exactly is an ice age? Well, an ice age, or scientifically known as an ice house environment, is a period in Earth's history where temperatures were significantly colder than they typically are. These ice ages are caused by a variety of different things, but oftentimes they're caused by a dramatic decrease in carbon dioxide in Earth's atmosphere. You see, carbon dioxide is what's known as a greenhouse gas, aptly named because it traps heat in Earth's atmosphere similarly to a greenhouse. Put simply, if there's more carbon dioxide in Earth's atmosphere, Earth will generally be warmer, and if there's less, it will be colder. The reason carbon dioxide increases and decreases often has to do with the life inhabiting Earth at the time. For example, 2.5 million years ago, bacteria that produce oxygen started to evolve in Earth's prehistoric oceans, which caused a reduction in greenhouse gases in the atmosphere. This caused the temperature to get colder, eventually getting cold enough for ice to form at the poles. Since ice reflects more sunlight than it absorbs, this made it even harder for Earth to retain heat from the sun. This process kept escalating until the entire planet, even at the equator, was covered in a thick sheet of ice in what is known as snowball Earth. Including this period, Earth has been hit with no fewer than 5 ice ages throughout its history, ranging in severity from just a little bit of ice at the poles to temperatures at the equator resembling those in Antarctica today. Some were similarly caused by an abundance of carbon-absorbing life forms, while others were caused by geologic processes such as a reduction in volcanic activity or a disruption in ocean currents. So, now that we know what an ice age is, what's the deal with the one that happened 10,000 years ago? Well, believe it or not, we are technically still in an ice age. This is because scientists believe that any ice sheets near the poles will constitute an ice age, as typically in Earth's history, temperatures have been warm enough for permanent ice to be impossible. The current ice age started about 30 million years ago, when the separation between Antarctica and South America due to plate tectonics effectively isolated Antarctica from warm tropical waters and enabled the growth of the massive Antarctic ice sheet. This caused the planet to start cooling, and this cooling was further exacerbated when the westward movement of North and South America helped to effectively isolate the Arctic Ocean from warmer ocean currents. Around 3 million years ago, North and South America were joined at the Isthmus of Panama, which effectively cut off water flow between the Atlantic and Pacific Oceans and allowed for enough moisture to accumulate in the Arctic that it froze over. This effectively kicked off the current ice age, and it has been ongoing ever since. However, the climate is not completely stable over long periods of time. As a result, Earth has been cycling between glacial and interglacial periods for the past 3 million years. These cycles are caused by subtle shifts in Earth's axial tilt, the shape of its orbit, and where Earth is in relation to the Sun at different times of the year. The influence between these factors is extremely complicated, but the end result is every 100,000 years or so, Earth cycles between periods with colder temperatures and ice sheets in the mid-latitudes, and warmer temperatures with ice sheets largely confined to the poles. The so-called last glacial period took place between about 100,000 and 15,000 years ago, and this is usually what popular culture means when the term ice age is brought up. Around 15,000 years ago, Earth began to warm towards the temperatures we're accustomed to today, but Earth's current climate is still significantly colder than it has been during the past. So, how is Earth different during the peak of the Ice Age? Well, for one, ice sheets extended remarkably close to the equator, with the Arctic ice sheets extending as far south as modern-day Chicago, New York, and Germany, places that we consider to be temperate mid-latitude locations today. The massive ice sheets themselves meant that sea levels were dramatically lower than they were today, up to 200 feet or 70 meters lower, in fact. This, in turn, exposed a ton of low-lying coastal areas that are submerged today, most notably the Beringia land bridge between present-day Alaska and Russia. It is this land bridge through which humans first explored the Americas about 30,000 years ago. In addition, many of the islands of Indonesia were connected to the greater Asian continent, and the island of New Guinea was connected to Australia. This allowed wildlife from both continents to cross onto these islands before they were separated, which explains why the wildlife in Indonesia is so similar to that of Asia, despite being geographically separate. Another dramatic change that is less correlated to the ice age itself, and rather to variations in sunlight that caused a cycle between glacial and interglacial periods as a whole, the Sahara Desert didn't exist. You see, right now the prevailing winds blow away from West Africa, pushing tropical waves out over the Atlantic Ocean, where they eventually become tropical storms and hurricanes, leaving Western Africa itself high and dry. Because of the slightly different intensity of sunlight thousands of years ago, however, these winds would sometimes reverse and blow onto Africa instead, bringing a monsoonal rain that was essentially a weaker version of the monsoon that hits India today. This made the Sahara region significantly wetter overall, which turned it from a desert into a sprawling savanna, not unlike the one that exists in southern Africa today. Finally, I would be remiss to make a video on the Ice Age without mentioning the most famous mammal that populated the time period, the woolly mammoth. Due to the colder climates found during this time period, the woolly mammoth and other so-called megafauna thrived, with many of these mammoths reaching sizes that would dwarf a modern-day elephant. However, thanks to the warming climate and human expansion, this woolly mammoth and other megafauna like it are now extinct. Alright, so what is going to happen going forward? Well, the cycles that control glacial and interglacial periods are predictable, so if nothing happens, a new glacial period would start in at most 50,000 years, and potentially in 10,000 years or less. However, ice ages are often started when carbon dioxide is removed from the atmosphere, and are ended when said carbon dioxide is pumped back into the atmosphere. Because of the enormous amounts of carbon dioxide humans have been putting out ever since the Industrial Revolution, some scientists believe that Earth will warm to levels not seen in millions of years before the current ice age even began. This may have the effect of either delaying the next glacial period or make Earth so warm that it never even happens. This is problematic because Earth changing so much in a geologically short period of time leaves almost no room for animals and plants, including humans, to adapt, which could potentially cause a mass extinction event, possibly on the level of the asteroid that wiped out the dinosaurs 66 million years ago. In the extreme long run, as in millions of years from now, ice ages as a whole will get less likely as the sun gets brighter, with it eventually becoming impossible for permanent ice to exist on Earth's surface. This topic of Earth's long-term evolution is so interesting that I could honestly make an entire video on that subject, so make sure to stay tuned for that. And that's all I had to say about ice ages. As always, I'd appreciate you to like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.